Good evening, everyone. Am I audible to all of you? Can anyone confirm once? Okay, I think I am audible. So
Yes, sir.
maybe we begin. So let me share the screen. So we were discussing some questions on differential equations, right? The entire portion that we have discussed till date. And this was the last question at which we stopped. We did not complete this. I had asked you all to try to work out this differential equation. So did anybody give this a try? Anyone? Okay, if not, then maybe let me take it up from this question and continue with the next set of questions for today. So the question was this. I'll just pick this. So this was the question, right? That if the integral curve of the differential equation this passes through the point 0, 0 and alpha comma 1, then which of the ones is alpha? And I hope you remember that we were discussing that integral curve means solution of the differential equation. The integral curve is just another term for that. And we had discussed that this differential equation basically looks like a linear differential equation in the dx dy format. So I'll just take that up as well. And when you have a differential equation like this, to solve it, you multiply it with the integrating factor, right? Correct. So anyone has any questions up till this part that we had discussed in the last class? Okay. So if this up till here, if it was fine, so let me continue with the solution of this. So after multiplying the differential equation with the integrating factor, this is what we got, right? Up till this step. So after this, the left-hand side can be written as ddy of x into the integrating factor, right? So this is nothing but d of x into e to the power y is equals to y e to the power y dy. And then you can integrate both sides. So the left hand side will be simply x into e raised to the power y. And what about the right side? Can anyone tell me? How should we integrate that? Anyone? So you have y into e to the power y, right? So You cannot substitute anything for the other. So this has to be solved by parts. Correct? And for solving it by parts, what do you need to use? You need to use the eyelet rule. So does anybody remember the full form of eyelet over here? What was this short form represent?
Inverse trigonometric, logarithmic, algebraic, trigonometric. Right?
Yes. So these are basically the short form of each kind of functions. And the order basically tells you that when you have to do integration by parts, which function needs to be considered as the first function and which one as the second. So in this question over here, the y is your algebraic function and e is your exponential function, right? So given that a comes first, y will be considered as your first function and e raised to the power y will be considered as your second function, right? In the integration by parts process. And does anybody remember how to do the integration by parts? Okay, maybe I'll just write down the formula once for all of you. So let's say that I have something like u into v dx, where your u is your first function and v is your second function. So the integration by parts says that this will be u integral v dx minus integral ddx of u into integral of v dx. Okay, u integral v minus integral of derivative of u into integral of v. So if I use this over here, so this will be y times integration of y dy minus integration of ddy of y into integral e raised to the power y dy whole dy. Right? Correct? So what will this become? X into e raised to the power y is equals to y e raised to the power y minus integral of derivative of y with respect to y is 1 and integral of e raised to the power y is e raised to the power y. So we have this and this will become x e to the power y is equals to y into e to the power y minus e raised to the power y plus c. Okay. So this is your general solution. Okay. Is it understood by all of you? Now we are given 2 points through which the solution will pass, right? So this is the general solution or the integral curve basically. So if the point passes through, if the curve passes through 0, 0, if you put that, you will get the value of c, right? So what is it coming out? Can anyone tell me? What is your c if you put 0, 0 in the equation?
1.
1, right? So that means x raised to the power y is equals to y e to the power y minus e to the power y plus 1. So this is your particular solution. Or this is also your integral curves basically. Okay. Now the point alpha comma 1 is also lying on this curve. So it will satisfy the equation. So if you have this, so this will be alpha times e raised to the power 1, which is e, is equals to 1 into e minus e plus 1. So what is your alpha? 1 upon. So which option is matching? It is option C, right? Okay. Is it understood by all of you? Any questions? Okay, perfect. So now let's move on to the next question for today. And this will be a subjective question. I will not give options for this. Let's say the question is something like this. Given that there is a common solution to the differential equation, DE1 is y dash plus 2y is equals to e raised to the power x y squared, where y of 0 is equals to 1, and differential equation 2 is y double dash plus 2y dash plus alpha y is equals to 0. Find alpha and hence solve D2. Okay, this is the question. So the idea is that you have two differential equations, both of them have a common solution. So if that is the case, we have to find alpha and hence solve the second differential equation. So can anyone take a guess? How should we proceed with this? Anyone?
The first equation is Bernoulli's equation,
Okay.
or we can substitute the d dash to the second equation.
And then
Then we have to find the alpha. I think it is a big sum.
you want to substitute y dash, you mean, from the first differential equation.
Yeah, into the second one.
Okay, if I try to do that, maybe so from the first equation, your y dash will be e to the power x y square minus 2y. And if I try to substitute it in the second equation, y double dash plus 2 times. Hmm, okay, so plus maybe alpha minus. And then how will you solve? So we need to find alpha and solve this equation. How can we do that from here? I do this.
I think then we have to go to the first option I said because it is becoming lengthier. We have to solve the Bernoulli's one with the initial value given, and then we put it in the second differential equation to find the value of alpha. It is going to be a lengthy process.
Yes, true. But if you are proceeding it in this way, so when you are substituting the y dash from the first equation in the second, you are getting a differential equation, right? Either you can solve it or find alpha. একটা equation থেকে দুটো জিনিস তো হবে না, right?
হ্যাঁ হ্যাঁ
Correct. Because you are not given any additional information about the solution that if you solve and get a solution in terms of alpha, and then you can use that to navigate around, that would be difficult. Okay.
yes.
So
I
this,
was thinking if I could do it in a one step, but no.
yes, yes. So this would be a little difficult because there isn't any additional information. It is just said that there is a common solution. That's it. We are not told anything about the behavior of the common solution or something that you can utilize in that manner. Okay. So the first step, or rather the process should be that we need to first solve for DE1. Okay. So my DE1 is basically y dash plus 2y is e to x to the power x y of 0. So if I just write it in a standard form, dy by dx plus 2y is equals to e raised to the power x y square. And like you have correctly identified, this is a Bernoulli's differential equation, right? And how do we know that? Because on the right hand side, along with the function of x, you have a power of y, right? So how do we proceed with this? Does anybody remember how to solve the Bernoulli's differential equation?
Divide by y square on all sides.
Okay, so you'll get y to the power minus 2 dy by dx plus 2 times y raised to the power minus 1 is equals to e raised to the power x. Okay, and then
We substitute y inverse and we get a linear differential equation.
so if you substitute your y inverse as v, then minus 1 y raised to the power minus 2 dy by dx is dv by dx. So that means y raised to the power minus 2 dy by dx can now be substituted as minus of dv by dx. So that means this will become minus of dv by dx plus 2v is equals to e raised to the power x. Or if I just adjust the minus sign, minus of e raised to the power x. And there we have a linear differential equation. In Vnx. Okay. So how are we going to solve this? What's the next step?
E to the
Just
power integration minus 2 is the
Correct.
integrating factor.
So the integrating factor is e to the power minus 2 dx. So e to the power minus 2x is your integrating factor. And then you will multiply the differential equation with the integrating factors, right? So e to the power minus 2x dv by dx minus 2v is equals to e minus of this into e to the power minus 2x. So this will become d dx of v into the integrating factor, and this will be minus of e raised to the power minus x. So d of v into e raised to the power minus 2x is equals to minus of e raised to the power minus x dx. And then you integrate it. So this will become v into e to the power minus 2x is equals to minus of e raised to the power minus x plus c. Correct? So v into e to the power minus 2x is equals to e to the power minus x plus c. Right? And what was my v? V was y inverse or simply 1 by y. So e raised to the power minus x divided by y is equals to e raised to the power minus x plus c. Okay. And then in order to find c, we need to replace y of 0 is equals to 1, right? So if I use these values, what is my c? Anyone? What is my c turning out to be?
1. No. Uh,
1,
0.
0. Yes, that's correct. Others, are we getting 0? Okay. So if c is 0, what is my final solution? So y of 0 is 1. That gives me c equals to 0. So that means my solution is e raised to the power minus 2x by y is equals to e raised to the power minus x. Or your y is basically e raised to the power minus 2x by e raised to the power minus x. That is e raised to the power minus x. Okay. So this is the solution of the first differential equation. And the question says that both the differential equations have a common solution, right? So that means this solution y is equals to e raised to the power minus x is also a solution of the second differential equation. Right? Okay. So if this is the case, then this differential equation must satisfy the second differential equation. So your d2 was y double dash plus 2y dash plus alpha y is equals to 0, right? Now y equals to e to the power minus 2x must satisfy d2. Correct? So using that idea, we can find out alpha, right? So can anyone give a try at finding the value of alpha?
Alpha is equals to 1.
Yes, I think that's correct. Let me just verify. So your y dash will be minus of e raised to the power minus x, and y double dash is e raised to the power minus x. So that means e raised to the power minus x plus 2 times minus of e raised to the power minus x plus alpha times e raised to the power minus x is equals to 0. So if I take the e raised to the power minus x common, this will be 1 minus 2 plus alpha is equals to 0. E raised to the power minus x is not 0. That means alpha minus 1 is 0. So alpha is 1. Correct. So that means your D2 is nothing but y double dash plus 2y dash plus y is equals to 0. Now we need to solve this once we have obtained alpha. So how to solve this? Does anybody remember?
We will take the auxiliary function
Which was
m square plus 2m plus 1 is equal to 0.
correct. Okay, so this is the second order differential equation, RHS 0. So we have only the homogeneous part. So for taking, so the auxiliary equation comes from the trial solution, right? So let y equals to e to the power mx be a trial solution, correct? So that means your y dash will be m times e to the power mx, and your y double dash will be m squared into e to the power mx. So if you replace that in the differential equation, you basically get m square into e to the power mx plus 2m e to the power mx plus e raised to the power mx is equals to 0. So e raised to the power mx will turn out common. So m squared plus 2m plus 1 is equals to 0. So e raised to the power mx is not 0. That means your m squared plus 2m plus 1 is 0, right? This is your auxiliary equation. So from here, what is your m?
-1.
1.
Minus 1. Correct. So both the values are minus 1, right? So repeated case. So then what will be the solution of this differential equation?
c1 plus c2x into e to the power minus x.
C1 plus C2x
Whole
into
into e to the
E.
power.
Yes, correct. Because this is the case of real and equal roots, right? Okay. Is it understood by all of you? Any questions? Any doubts in the process? Okay. Let me discuss one more subjective question today. Let y of x be the solution to the differential equation where y of 0 is equals to 2 and y dash of 0 is equals to 2 times alpha. Find the values of alpha where alpha belongs from open interval 0, sorry, closed interval 0 to open interval 1, such that y of x is greater equals to 1. Okay. So how can we start? Can anyone take a guess?
We will solve the second order equation first, differential equation, and get the constants from the initial values, and
Yeah,
then we will put to find the inequality.
correct. So first of all, we have the differential equation as d2y by dx2 minus y is equals to 0. So let e raised to the power mx be a trial solution, right? So that means if I put this in the differential equation, this will be m square into e to the power mx minus e to the equals to 0. So e raised to the power mx not equals to 1. So that means m square minus 1 is equals to 0. So what is m from here?
Plus minus 1.
Plus minus 1, right? So that means it's real and distinct case. So your solution, the y of x is c1 times e to the power x plus c2 times e to the power minus x, right? Okay. So from here, we are given two initial conditions and then we need to find out c1 and c2, right? So the first is y of 0 is equals to 2. So if I put that over here, y is 2 and x is 0. So 2 equals to c1 plus c2, correct? This is basically your first equation. And the second one is given as y dash of 0 is equals to 2 alpha, right? So what is y dash of x? It is c1 e to the power x minus c2 e to the power minus x, right? That is your y dash function. So if I put y dash of 0 equals to 2 alpha, that means 2 alpha is equals to c1 minus c2, right? So using these two equations, we need to solve for c1 and c2. So can anyone quickly solve it and tell me what you are getting?
One plus alpha and one minus alpha.
C1 is 1 plus alpha, right?
Yes.
And C2 is 1 minus alpha. So your final solution is y of x is equals to 1 plus alpha times e raised to the power x plus 1 minus alpha times e raised to the power minus x, right? So this is our final solution. And what do we have to do? We want to find out values of alpha such that y of x greater equals to 1. So y of x greater equals to 1 means what? 1 plus alpha e raised to the power x plus 1 minus alpha e raised to the power x minus x greater equals to 1. Right? Using this, we want to find values of alpha. Correct? So how can we proceed from here? Can anyone tell me?
We can take three cases: x tends to plus minus infinity and x tends to 0.
Why do we need to take these three cases, Madhurima?
তাহলে ভ্যালুটা বোঝা যাবে, মানে দুটো এক্স এর কি ভ্যালু হতে পারে সেটা যদি আমরা দেখি তাহলে বোঝা যাবে যে আলফাটা কোথায় যাচ্ছে আর কি কি লাগবে।
তো আমি যদি মানে x টেন্ডস টু ইনফিনিটি বললে, রাইট? যদি x টেন্ডস টু ইনফিনিটি ভাবি, x টেন্ডস টু ইনফিনিটি মানে হচ্ছে e raised to the power x tends to infinity, আর e raised to the power minus x হচ্ছে tends to 0। তার মানে ইনফিনিটি প্লাস 0 গ্রেটার দ্যান ইকুয়ালস টু 1, সেটা তো অলওয়েজ ট্রু হবে, মানে তাই না? মানে এটা যদি আমি রিপ্লেস করি, মানে বেসিক্যালি কামিং আউট লাইক ইনফিনিটি গ্রেটার দ্যান ইকুয়ালস টু 1, মানে এখান থেকে আলফার ব্যাপারে কি পাবো? কিছু তো পাচ্ছি না।
আচ্ছা আচ্ছা, ওকে।
কারেক্ট। মাইনাস ইনফিনিটি করলে রিভার্স কেসটা, মানে আবার ইনফাইনাইট গ্রেটার দ্যান ইকুয়ালস টু 1 আসবে। Anyone else? So this won't work. Anything else that we can try?
এই ইনইকুয়ালিটিটা কি আদৌ আলফার উপর ডিপেন্ডেন্ট থাকবে, মানে ফর গ্রেটার দেন ইকুয়াল টু 1? আমরা যেটা
নাও হতে পারে, নাও হতে পারে, মানে ইটস নট ম্যান্ডেটরি, মানে হয়তো বেরোলো দেখি ফর অল আলফা যে রেঞ্জটা দেওয়া আছে কোয়েশ্চেনে, হয়তো দিস উইল অলওয়েজ হোল্ড টু, সেটাও হতে পারে, বাট we need to verify that, right? We cannot assume যে ওটাই হবে, ডিপেন্ডেন্ট থাকবে না। That cannot be assumed. That needs to be calculated and verified, right?
ওকে।
Anyone else? Okay, what about this? If I just try to solve this in this way. Is this making sense, Dolphin? What I've done over here? Right. Now let's say if I just use a simpler notation, this might look a little weird. So if you, let's say, substitute e to the power x as, I don't know, maybe some p, what do you get? Can all of you observe that this is nothing but a quadratic in e raised to the power x, which is your p? Yeah? Agreed? So if I define this as my So this entire quadratic is, let's say, some function of p. Okay, let f of p be equals to this. 1 plus alpha p square minus p plus 1 minus alpha. Then the question that we are trying to find out is that we want to find alpha such that f of p is greater equals to 0. Right? Correct? We want to find such values of alpha such that this quadratic is always positive. Right? Agreed, everyone? Is this making sense?
So can you repeat?
Which part?
Last part, like after assuming if p equals to 1 plus alpha.
Yes, so
Yeah.
we want to solve this equation, right? 1 plus alpha p square minus p plus 1 minus alpha greater than equals to 0, right? So if I define this as my f of p, then I basically want to find the values of alpha for which f of p is greater equals to 0, right? RHS में greater equals to 0 है. Correct? वही
Yes.
निकालना है मुझे, right?
Correct. Okay.
Right? So I want to find out the values of alpha for which f of p is greater equals to 0. Now, if you remember one thing, so for any quadratic, right? यहाँ पे मैंने f of p लिया है, so that is fine. Like, how does the graph of a quadratic look?
The coefficient of p square will be positive and the discriminant should be imaginary. Give us imaginary roots.
Sorry, repeat once more. What are you saying?
1 plus alpha should be positive and
Why?
yeah, it is the upward, we get the upward curve.
Upward curve. Okay. And discriminant should be?
Less than 0.
Okay. Okay. Let's discuss this once. Okay. So let me just consider a general quadratic. Okay. So let's say that your fx is ax square plus bx plus c. All right. Now, in general, the quadratic takes the shape of a parabola, right? It is either an upward U or a downward U. Correct? So if you remember, there was or rather, I can just show it to you over here as well, that if a, which is the coefficient of x square, if it is positive, then you always have a upward parabola. And if a is negative, then you have a downward parabola. Okay, that is the idea. All right. Now over here in our question, what is the coefficient of p square? It is 1 plus alpha, right? Correct? And what is the value of alpha? Alpha belongs from 0 to 1. So 1 plus alpha is positive. Correct? So we are only focused on the upward looking parabolas, right? Now look at it once more. We want to find out the values of p, or according to the graph, the values of x for which fx is equals to 0, right? Greater than 0, right? Now, if the parabola looks like the one that I have drawn over here, it has real and unequal roots, right? If there are real and unequal roots, then for this range of values of x, you have the functional value becomes negative, right? So this is not applicable. If you have real and equal roots, which is the case where your parabola just touches the x-axis, in this case, your fx is 0, right? The minimum possible value, fx is greater equals to 0. And if it is not touching, that means the roots are imaginary or complex, then for all values of x, fx is strictly positive. Correct? So can I say that for fp to be greater than equals to 0, the discriminant should be less than equals to 0. I also need to take the equality case, right? Because the question says fp greater equals to. So that means the discriminant can be equals to 0 as well. Okay? Is it understood by all of you? Is it making sense? Any doubts, anyone? Is this idea fine? So if discriminant is positive, then we cannot take it. If discriminant is equals to 0, that is fine. And if my discriminant is negative, that is fine. So that means for fp to be less than greater than equals to 0, my discriminant should be less than equals to 0. Okay. Now what is the discriminant of this equation? Can anyone calculate and tell me? What is it coming out? What is the discriminant of this f of p? Anyone? What's the discriminant? B square minus 4 into. Right. So discriminant less than equals to 0 implies 1 minus 4 into 1 minus alpha square should be negative. Right? So minus 3 plus 4 alpha square negative. That means 4 alpha square should be less than equals to 3, or alpha square should be less than equals to 3 by 4. So if alpha square is less than equals to 3 by 4, then what should be the values of alpha?
Plus minus root 3 by 2.
Only plus minus root 3 by 2, or
0
the
to
range between that?
from 0.
minus root 3 by 2 to
Plus
plus
root 3 by 2. So inequality, right?
Correct, correct. Yeah.
Okay. So maybe I'll just write this down once more. So if you have x square less than equals to a, what does that tell you? That x lies between minus a to a. And if you have x square greater equals to a, then it basically tells you that x belongs from minus infinity to minus a union a to infinity. Correct? So that means by solving this inequality, we get the value, the range of alpha is from minus root 3 by 2 to root 3 by 2. And as it is given in the question that the range on which we want to find out the value of alpha is 0 to 1. That means what will be your required range of alpha? Closed interval 0 to root 3 by 2. Okay. So this is the range of alpha for which your y of x will be greater equals to 1. Okay. Is it understood by all of you? Any questions? Any doubts? Okay. All right. So I think we can stop here for today. I think the last question might have been a little difficult for all of you. So in case if you all are still having some questions or doubts, do let me know in the next class and we can discuss this once more as well. Okay. And just as a heads up, tomorrow's maths class will also be taken by me. So we'll discuss a few more questions of differential equations and some other doubts if you all have. And then we'll finish the chapter on differential equations tomorrow. Okay. So thank you everyone for joining. See you all in the next class, which will be tomorrow. You all can disconnect. Thank you.
Thank you.